If you sort all the numbers from 1 to a billion, but not by their value, but alphabetically, like in a dictionary, what's the millionth number you'd find? It's a tricky question, and the answer is surprisingly elegant. We're going to solve that today. This is day 55 of coding every day until I hit 1K subs. Today, I started a neat little automation project and then jumped into a couple of related LeetCode problems that deal with that exact dictionary sorting puzzle. Let's get into it. Alright, so first up, I kicked off a new project. I'm calling it Commit Journal, and the idea is to create a Python script that automatically pulls my latest GitHub commits. I wrote the initial README to outline the main purpose and features. It's designed to grab recent commits, pull repo info, and even get the README content, which is useful for logging my work. Next, I fleshed out the setup instructions. It's a pretty standard Python project, so you'll need a personal access token from GitHub to let the script access the API. I've listed the dependencies, which are PyGithub for the API interaction, and python.env to handle the token securely. Then it's just a matter of cloning the repo and installing the requirements. And finally, the usage part. Running it is as simple as executing the main Python script. It then handles authentication, fetches the data, and sorts the commits into two separate output files. One for all recent commits, and one for just the new ones since the last time you ran it. It's a simple but handy tool for tracking progress. After setting up that project, I decided to tackle some LeetCode. First up is problem 386, Lexicographical Numbers. Spoiler alert, the goal is to take an integer n and return all the numbers from 1 to n sorted in lexicographical or dictionary order. For example, 10 comes after 1, but before 2. Alright, here's the solution. This approach iteratively generates the numbers without using any extra memory for recursion. It cleverly simulates a depth-first search on a conceptual prefix tree of numbers. The logic follows three simple rules. First, try to go deeper by multiplying by 10. If you can't, try to move to the next sibling by adding 1. If you can't do that either, you backtrack up the tree until you can find a valid next sibling. This achieves an efficient order n time complexity and order 1 extra space. That last problem was a great warm-up for this one. Number 440, kth smallest in lexicographical order. This is the hard version. Given n and k params, we have to find the kth number in the lexicographical sequence, but n can be up to a billion. This means generating the whole list is not an option. We need a much smarter way to jump to the kth position. This solution is really clever. It treats the numbers from 1 to n as a ternary prefix tree. Instead of visiting each number one by one, it calculates how many numbers or steps exist between a number and its next sibling. For example, it calculates how many numbers start with 1 before you get to 2. If our target rank, k, is greater than that count, we can skip that entire block of numbers, subtract the count from k, and move to the next sibling. Otherwise, we know our target is in the current block, so we move down a level and repeat the process. This allows us to jump across huge ranges of numbers, making it incredibly fast. And that's a wrap for day 55. We kicked off a new automation script and solved a couple of really interesting lexicographical sorting problems. If you enjoyed it or learned something, a like and subscribe would be amazing. Let me know in the comments if you've ever seen a problem like this before. You can also support the channel over at buymeaboba.com, link in the description. Thanks for watching, and I'll see you tomorrow.